So yeah, welcome to Module 2 of Balancing Building Performance, Risk and Reward. Today we're really going to focus on the design
phase, yeah.
design phase of what we do. And yeah, if you guys have any questions, we don't yet have Module 1 available on a website. Is that correct?
It's posted to the internet so people can get to it on YouTube. We're working out all of the details for sharing media content on our website, and fairly soon we'll have a really good platform, but all of these items will be available.
Okay, so yeah, if there's an emergency and you want to watch Module 1, we have that on YouTube, and I have the link to that so we can pass it along. But all of the resources that we are passing along will be available soon. So thank you, Malachi. So today we are in the design phase, talking about energy target setting and modeling, and we're really going to talk a lot about ASHRAE Standard 209. So you're probably going to get sick of it, but we're going to be talking about defining the scope and managing the execution through the design phase. Again, I'm Allison Johnson, here Sustainable Design Leader in the St. Louis office.
Annika Landrino, I'm our Sustainable Design Director. I'm based out of Washington, D.C., but I work across the firm.
And Donovan Olive, General Counsel for HOK, based here in St. Louis.
But he works on all of HOK's projects.
I work on everything.
Just like me, all of HOK.
Touch all aspects of HOK.
So just as a really quick review, we have a lot to share today, but we will be quick and just remind ourselves of why we're talking about this. BEPS, the Building Energy Performance Standard, and the general timeline is that we started in 2017 benchmarking so that we would have data in order to pass and establish thresholds as we move into that, move into this new phase. So we are in BEPS Cycle 1, which was passed in 2020 by our aldermen and women. The targets were established in 2021, so last year, and there are 4 years between May 2021 when they were established and May of 2025 when you have to prove compliance and the first cycle ends. And then the cycle starts in 2025, but we won't have targets until 2026, May of 2026, because it takes about a year to get all that data together, and then we'll be moving that threshold. So this is a timeline in a kind of bigger sense and how it works cyclically. So we talked about the first 4 items, on the left side of this timeline, and then so May 2021, the first cycle, BEPS thresholds for EUIs were established for each project type based on our buildings in St. Louis. The first BEPS cycle ends in May 2025 when you have to be compliant with that 3565 threshold, and I'll talk about that in just a second. And then the new cycle begins immediately, but we will have the target for May 2030 in May of 2026 will be established, and then it goes on. So the third cycle then starts in May 2030 and ends in May 2035. And the first 3 cycles there's a few different clauses in there, so that's why we highlighted those 3 cycles specifically. This is the distribution chart, and just a reminder, like every dot on here is a building in St. Louis, and the blue line represents where the top performers and the lower performers are on each of the lines. So another way to put this, and I think Emily put it best, if you are not performing in the top 35%, if your building doesn't perform in the top 35% of all of the buildings in your category in St. Louis, you have to do improvements by May 2025 for the first cycle. So that's where that 3565 mark exists.
So what we really want to talk about is how designers manage risk in the design process. So, and working in concert with owners. When you are designing a building or doing a renovation on an existing building, how do you design not just for code, but also to be compliant with BEPS in the future? Because once a building is delivered, it's an existing building and it will have to be compliant with BEPS forever. And so we want to talk about how we leverage energy modeling to get iterative feedback throughout the design process as one of our key risk management tools. So the AREA has done studies, and they said that when energy modeling is used in design, those projects are 32% more efficient, more energy efficient than projects that don't leverage energy modeling. Now, some folks are like, maybe the project without a model is just as efficient, you just don't know, right? There's just no feedback. Having worked on projects under a lot of different scenarios, I can say it's much harder to protect the energy performance of a project through all of the iterations of value engineering when you don't have a feedback mechanism to say, if you do that thing, you're no longer going to save that energy. You're going, suddenly the energy savings is going to erode. It's going to erode very quickly. It's very hard to protect the performance of the project. Suddenly there's just a line item cost savings without, an energy savings trade-off to balance that out. And so we find that those savings do erode really quickly throughout that value engineering process without a model, without understanding the peak load trade-offs or the energy performance trade-offs. So the AREA does have an architect's guide to energy modeling, but it's very visual, which is good for architects, but also very sort of qualitative. And so we find that one of the best tools to help define scope for architects, owners, and our consultants is the ASHRAE 209 standard, which Donovan spoke of in our first module. And he mentioned it's kind of a cafeteria approach. There are some minimum requirements, some fundamentals that are baseline for using the standard. And then there's a menu of modeling cycles that you can opt into depending on the scope of your project. But essentially what we think it's a good tool for is basically determining what kind of models do you want, when do you want them in the design process, what kind of feedback are you looking for, when do you want to do workshops, who should participate, and what cycles are you going to include in your basic services and which are you going to exclude as add services because you're not sure if you need them or not. It's going to depend on the project.
So, you're going to do this one.
Okay,
go ahead.
So this was set up as a standard that jurisdictions could adopt as a code. Now, St. Louis has not adopted ASHRAE 209. We just think it's a good best practice. So we have set this up in our firm as infrastructure to help us with risk management. There are dozens of jurisdictions that have adopted building performance standards or are in the process of adopting building performance standards. So we feel like this is a good risk management tool for us as a firm. I just want to be clear that when we're saying these are minimum requirements, that's how the standard sets it up. It's not required by this jurisdiction. We just think this is a good best practice for firms to adopt. So the standard has a minimum requirement of following the general requirements, section 5, a minimum requirement of modeling cycle 3, which is load reduction modeling. So before you do anything else, reduce your loads. And then choosing one of these models, which they consider design phase models, cycles 1 through 7. Just at least one. You can choose more, but at least one of those cycles.
Yeah, and then these are optional, considered optional, as far as ASHRAE 2009 is considered, but have different purposes, and we'll go through each of the different models.
The construction phase cycles will go through in module 3. So we're just focusing on the design phase in this module 2.
Correct.
So this is how all of those cycles of modeling that we just went over layer over a design and construction project schedule. So if you're looking at concept and SD and DD and CDs and CA, et cetera. So the top bar is ASHRAE 209 modeling and kind of mapped out over the project schedule. And we also layered on commissioning activities because we think commissioning is also a really key step in managing performance and risk in these jurisdictions with building performance standards. And then the stakeholder workshops. Again, that's how you get all your stakeholders together and touch base on those goals. So it's a lot of modeling, and we hear that a lot. Our colleagues around the firm are like, that's a lot of modeling, like that's fee, and the clients are gonna freak out. We've done studies, and we've been doing studies for years on what it costs to do energy modeling and what we save when we do energy modeling. And you saw the AIA study, the 32% delta. What we have found, if you just look at the cost of modeling, and then you look at the energy savings that building has, most of the time, the building saves as much money as you spent on energy modeling in the first 1 or 2 months of occupancy, just from being a more efficient building. Sometimes it's 3 or 4 months, but it's really fast. It's practically instant. Like, who wouldn't do something that paid for itself in 1 or 2 months? We have had some complex buildings where you're like, oh, it took 7 months, but it pays for itself really, really fast. And that's when you're only looking at operational savings. When you look at peak load reduction, system right sizing, construction cost savings, that's absolutely 0 months. You've paid for it in construction because you've been able to right size your systems. So we did a study. It was published on the Department of Energy website. I think they call it the shockingly short payback of energy modeling. They were really excited to see architects doing that kind of research. And so one of our engineering consultants actually saw the study, and they said, well, that's one architect, lots of engineers. I wonder if we did the same thing, we dumped our data into that kind of evaluation, if we'd get the same results. So one engineer, lots of architects. They said pretty much anything over 25,000 square feet absolutely paid for itself well under a year. Once you got on the smaller side, sometimes it got a little closer to a year or longer payback. And so not that, sometimes it did pay for itself in well under a year, but sometimes it took a little longer, and it just depended on the project. And so for BEPS, all of these buildings are 50,000 square feet and up. So we'd say pretty much all of the time, energy modeling is going to pay for itself pretty darn quickly. So even though we just 6 months, even though we just showed you a lot of energy modeling cycles, we think it's something that's a no-brainer. The value is obvious, that it pays for itself really quickly, not just in risk management, but just in the energy savings, and the value to the owner.
So really, ASHRAE 209 is not required, again, by our jurisdiction, but it aligns with the requirements we have in city. So the simulation software requirements for 209 are very consistent with IECC 2018, whereas as soon as you deviate from the prescriptive path of your building, an energy model is required. Energy modeler credentials are required, climate and analysis parameters for simulation, benchmarking, which we do as a city, that was predated the BEPS program, the energy charrette, where you establish goals, set goals, and establish strategies for energy saving in your project. And then the energy performance goals and setting, it really sets the stage for BEPS so that you guys are on the same page and you know what your kind of sunset date will be of complying with those thresholds. And then lastly, the general modeling cycle requirements that establish things like baseline goals, input, output, QA, QC reviews. And then in the iterative design, integrative, when you have a word in your head, and you just can't, anyway. Integrative design process, it really aligns with LEED's integrative design process, but the concept design phase is where you establish do some site analysis, and then do your benchmarking, and then a simple box model. And that is like the first step in figuring out size and shape and what those things that could affect your energy model are. Sometimes we get to do them because we start in concept phase, but it really is, or sometimes we do them in concept phase, sometimes it's early schematic design, but that is like the first energy model that is established.
Not all projects pursue LEED, but if you do, there's a credit for doing this.
Yeah, so in 4220, we have some data there. It was energy modeled, and you can see, things like window to wall ratio and the shape of the building. All of this was analyzed in those early processes, and now we know, based on the benchmarking data, that we have exceeded BEPS, threshold by a little over 25%. So I think this one will be good through the first cycle and into the next.
But this is exactly the kind of thing, when this project was started, when you're having your energy charrette, you set a goal for the project and you want to look not just at benchmarking against the code, but forecasting BEPS and saying, where do we want to be against BEPS to make sure it will comply with BEPS as well as the code.
And I know that things were tweaked in the process by using, those window to well ratios, those kind of low-hanging fruit items and what it affects. Were you going to say something?
Oh, I was gonna say this, so the EUI on 2021 was measured at 59,
Measured.
and then what is the 71.7?
That's the standard. So it has to be,
Oh.
it has to be below that to
Oh,
be
okay,
compliant
okay.
with BEPS. But the standard will continue to get lower over time because more energy efficient buildings will come online. And as the worst performing buildings,
Everyone
become
gets
better.
under that mark, hopefully.
Just more stringent.
as the worst performing buildings have to improve in order to meet BEPS, then the percentile, that line moves. And so
Right.
the standard will continue to adjust downward.
That's
And
BEPS
then-
cycle 1 for an office building. It's
Okay.
not necessarily account for, there's not a whole lot of labs in this building, but it does not, like the calculation hasn't gone through the energy,
We
net
haven't done a
zero.
weighted average.
It's not a weighted average yet, but that's,
And then is there differentiation between new building versus old?
No, BEPS applies to all existing buildings, whether they were built yesterday or 20 years ago or 100 years ago.
over 50,000 square feet in the city of St. Louis. That's what's been
And
passed.
then what, I might be just late here, but what's been benchmarked so far? What percentage does that represent of the building stock that is over 50,000 square foot? Like,
So the city has around 1,200 buildings or 50,000 square feet. We exempt buildings from benchmarking and BEPS if they have manufacturing
okay,
or industrial processes.
which probably a lot of them.
Yes, around 300 so far.
Okay.
And the building owners can apply for exemption on annual basis.
You have a higher vacancy rate or something else? and
Yes, on that
essentially-
too, yes.
So another example is the Grand Flats project. And so this is an example of setting like really low targets, high targets, however you should.
Aspirational target.
Aspirational targets is a better word. And, getting there by over 50 or about a 50% reduction, which actually would exempt you for cycles 1, 2, and 3 according to the BEPS rules.
Yeah. And so when you were doing your energy charrette, that's the kind of thing you'd want to talk to a client about. At the very beginning of design, are you interested in setting a target that might automatically make your building compliant with cycles 1, 2, and 3? Some of our clients like to sell a building soon after delivery. And so if you're trying to make it attractive for,
This is a good point. Yeah. So
trying to make it attractive for an equity fund or another type of, building investor, saying this is already positioned to be compliant for the first 3 cycles is a really good move. And so, and especially now when, a lot of investment funds, ESG is at the top, of their list. And so saying, hey, this is already a super green building, it's already compliant for BEPS. And so this is one of the goals you might set at that charrette.
yeah, and maybe no capital improvements in the first 3 years of owning the building.
Right.
So
Well,
Which is awfully
and that's
attractive.
great for a stick-built residential project, that's great.
yeah.
Yeah, so to know that no capital improvements will be needed, at least not for BEPS compliance, is a great positioning.
To sell a building.
Yeah.
This one, me too.
Can't recall.
Okay. So the first, we talked about simple box modeling. It's really strongly recommended as a basic service and included in that. It does align with IACC 2018 and would support, because it has to do with those major moves that can happen early in the design process. And then it also aligns with the integrated process credit for LEED, and it's usually performed in concept or early SD, as I said.
It's sensitivity analysis. So what is going to have the most impact on energy performance for the building? Is it window to wall ratio? Is it orientation? Is it mechanical systems? Is it something else? So it's identifying what those things are and knowing which avenues to explore further and which ones are not really going to have a big impact. I remember we had a hospital in Germany once and we found out that orientation had almost no impact because the cloud cover was so pervasive that solar radiation wasn't a big driver of energy. And so we said, okay, so we're not going to worry about orientation. We're going to focus on some of the other design moves, which was good. We knew we had some freedom on the orientation side. We could really focus our efforts elsewhere.
Yeah, so the next one is conceptual design, which consider optional. Sometimes you get a chance to do this and sometimes you don't. In a situation where you had a 0 lot line, for example, and you know your building is only going to fit on your site a certain way, it's kind of negligent. You know, it's a moot point at that stage. So usually this is performed by the architect, sometimes engineering or engineer consultant, but it's really it happens if we have the chance to still influence the massing or the orientation of your design.
So this is the cycle that the 209 standard says should be mandatory. No matter what else you do, you should definitely do the load reduction modeling. And that's because this is the key opportunity to reduce construction costs, to right-size your systems. And this is really both a annual operating cost savings and a construction cost savings. This is one of the biggest opportunities. And too often the architect designs the building and there's a huge curtain wall facing southwest or something like that, and then they hand it to the engineer and say, go ahead. And they've already created the loads. The loads are already done, and then they hand it to the engineer who now has to try to address those loads as efficiently as possible. So this cycle is really about focusing on load reduction. And so it focused. Again, you'll still get annual energy savings. If you focus on load reduction, you're still going to get all of the benefits of annual savings. But this is focused on peak heating and peak cooling loads and how you can whittle those down. And so one is going to address payback in annual energy expenses, and the other is addressing payback in construction costs because you want to right size your systems. So ASHRAE 209 says do this before you select your HVAC system because you might make different decisions when your load profile has changed. A really good example of this, kind of almost in the inverse though, this is a Royal Caribbean headquarters in Miami that we were doing, and they're on the water. They wanted a lot of view in daylight. And so you can see that we tried to use these slab edge extensions to shade the window walls so that we would not get too much solar radiation on them, and so we optimized that, to really protect from solar heat gain and to reduce the cooling loads. And our client didn't want to, at some point they're like, oh, maybe it'll block my view, even though we did virtual reality and everything. And even though some of those slab edge extensions are like terraces and provide amenities, they sort of said, maybe we could just pull those back a little bit. So we did some modeling and said, if you pull those back, we're going to end up having to reduce the window to wall ratio by 50%. We're going to have to add all this extra insulation. We're going to have to really beef up the U value of the windows. So go ahead to the next one. And we looked at the peak loads and we said basically the annual energy impact is only about 5%, but the peak load impact is huge. And so we're also going to increase your central energy plant by 13%. We're going to increase all the sizes of the mechanical closets. Here's the impacts, the chillers, the cooling system. This is the impact in hard costs in construction. So don't worry about your 5% annual energy costs. Worry about the first cost impacts of eliminating those slab edge extensions. This guy had dithered forever on improving the enclosure design. As soon as we showed him the impacts to first costs, he was like, we're done here. Like, I'm improving the enclosure design. We're moving on. Like, next question. It can really help make some decisions when you really focus on construction cost impacts.
So the next one is 6.4 HVAC system selection. And really, this is a chance to do life cycle or life cost analysis and compare different systems and how much savings over time that might exist. So we did this on a recent project on Moss Courthouse, Federal Courthouse in Salt Lake City. We did not look at ground source heat pump as an option because it was an urban site and we were bound, that was not a possibility. But we did look at chilled beams and we looked at BRF and DX systems and ultimately ended up not going chilled beams route. But we were, because there wasn't much of enough of a savings to warrant the lower ceilings and, some of the things that would have had to happen. So, but it was required by GSA in order to do those so that they had a clear picture of what kind of system they were going to be buying and, using federal funds appropriately. So it usually happens in late SD or early DD.
So then once you've chosen an HVAC system, now we're looking at design refinement. And so this, depending on the scope and complexity of your design, you may have multiple cycles of this. You might be looking at 50%, SD, 100% SD, 50% DD. The number of iterations and where they occur is really going to depend on the scope and complexity of the project. You might only do it once, it really depends on the project. So we have some projects with a lengthy schedule. They're complex projects. There might be 2 or more iterations, but some you might only just hit it once. And so we don't mean this to be prescriptive, this is exactly when it has to happen. Go ahead. And so this design refinement is really when you start to, you're organizing your program in the building. So you're modeling based on the location of the program, based on the building orientation. You understand where your occupants are, how they're using the spaces. You understand more about your systems. Certain plug load impacts, lighting impacts, and things like that. The example I have here, we did a consolidated forensic lab. The top floor is the chief medical examiner, the morgue. It had the highest air change rate requirements, so we put it next to the penthouse to shorten the duct run for that. So that reduced some of the energy there. Go ahead, the next one. We also put all the labs on the north for sort of free daylight, indirect light without glare. We had the offices on the south side where we could use a louver system to control glare. So, and then we had 100% outside air, but we had a complete energy recovery ventilation system, and we used chilled beams in this case. So this is the high level modeling. We don't have all the subsystems and all of the operational parameters, but we are starting to understand how the building will function and how the program is laid out in the building.
And then the next phase.
Yeah, this is design integration and optimization. So this is the next level of detail. And again, depending on the scope and complexity of the project, you may have 1 or more iterations. This might go mid-DD through mid-CDs, and it really depends on your schedule for your project. And so
So this is strongly recommended as a basic service, and really it's starting to become more detailed. So getting all your enclosure materials in and accurate, your subsystems to your MEP, your actual glazing systems and the glass types, your sensors and controls, and then starting to get into scheduling and those kind of the things. So yeah, we usually have check-ins personally at 50% or close to the end of that.
And this, for example, this was an inpatient mental health care facility in Oregon State. Go ahead. And so, you have your specifications. We're doing a really tight thermal envelope here, leveraging day lighting. We're also leveraging some setbacks, demand-controlled ventilation in patient rooms. And then energy recovery ventilation. We also did things like night flushing in certain spaces like the gymnasium. We were able to get our loads down enough that we were able to completely trade off chillers and boilers and air cooling towers for this ground source heat exchange system. So we completely got rid of those traditional pieces of equipment and did all the heating and cooling with a ground source heat exchange, and that was cost neutral. And so, but this is where the setbacks, night flushing, all of the details of operations can be modeled because you have all that information.
Yeah, so the last one in this section is really focusing on using the model in order to aid. We all come to a point in the project where it's over budget and they want to cut certain things or they want to go to a cheaper system. And sometimes, it can go either way. The model can help prove that that's a smart move, that certain things don't matter, but it also can protect the energy savings. So Annika's example is why don't you swap out that fancy Italian marble and we'll keep our energy recovery systems because it makes the most sense for the project overall. So it's really simulation aided value engineering is the
Sometimes that's energy simulation aided value engineering. Yeah, that's a tongue twister.
And the example we have here is a project where they're really close to the peak loads. The peak loads that were just right on the bubble between different things. It was a project that was sold mid-construction, but developer project, And
It was over budget, the mechanical package was over budget in DD. And so we were in a value engineering process and our engineers said, hear me out, what if we went with more expensive glass, but less glass? And so minor adjustment in the window to wall ratio. But we were, as Allison said, we were just on the cusp of the peak loads where once we reduced, we were able to get rid of the chiller. And so getting rid of that chiller and reducing the glass, even though we went with slightly better glass.
it was like 59% to 51% or something.
Yeah,
right?
it was 56 to 51%
Okay.
window to wall. So it saved $500,000, brought the site EUI from 32 down to 28. So we actually improved the performance of the building while saving $500,000. And as Allison said, our client had already sold the building while we were in site work and foundations. So the client wasn't waiting for long-term payback over a year or two. They were getting their payback, immediately in construction costs.
I think this is important to note because, in St. Louis, we have cheap energy. And so sometimes we can't use that as our excuse for payback long-term, but sometimes there's upfront payback if we just, do some minor adjustments, and I think the project's better for it, long-term and short-term.
I don't have any clients that will turn down $500,000 savings, right? Like they may turn down a year or two payback or a 5-year payback. None of them will turn down $500,000 in the pocket. Just won't happen. So this is the as designed energy performance. So when you have completed the design, submitting for permit, all the changes picked up. Value engineering, anything that happened. Sometimes people do this for their permit. Sometimes they'll do it for lead documentation. Often the permit model is like a 95% model. What we want to make sure happens, because this is risk management, if there are any changes that happen after the 95% of the permit model, you pick those up and you finalize that model, because we need a record of the design that went out for construction. Because we need to be able to reference back to that if there's ever an issue with the building. So we highly recommend that there is an as designed, accurate as designed. This is what was issued for construction energy model. When the next module, we'll talk about what happens if there are changes in construction, but this is issued for construction. This model is accurate with all the decisions that were made to date. And I'll just really quickly, people ask us all the time what tools we recommend for energy modeling, and it really depends on when you're modeling and what kind of information you need. In concept, there are some free tools that we like to use, Ladybug and Open Studio. Climate Studio is a really good tool. It does require a license, but we like it a lot. And then when we get into schematic design, a lot of times we'll use, in our Revit software, we'll use Insight 360. And then for whole building energy modeling, we really like IES. That is a licensed tool. It does have a fee associated with it. A lot of our engineers will use Energy Plus and eQuest. Those are free and based on the J2 platform. There are pluses and minuses with those. You can go ahead. There's a white paper that was done a few years ago on these, and we find, so Energy Plus takes a little longer to run, but it is a lot more nuanced and a lot more reflective of more high performance buildings that are more complex. eQuest runs faster, but it is much more simplified. So that's why it runs faster, but it doesn't reflect high performance building design. So I'll use an example of a hospital we're doing in DC under eQuest. It modeled at 178 kBTU per square foot per year. When they took that same building into Energy Plus, it modeled at 148 because eQuest just couldn't capture all of the systems as designed and all of the nuance. But once we got into Energy Plus, it dropped 30 kBTU in the model. So we weren't able to see what we were doing in eQuest. We were able to see it in Energy Plus. Now, none of that matters once you get into benchmarking. It's all about performance. But if you're really trying to understand the impact of your design, it's helpful to have a model that can get into that. So if it's a simple building, eQuest is fine. It's a more complex building and you're leveraging higher performance systems. Energy Plus is a better tool. Now Donovan's going to talk about contracts.
Okay. Okay, so in module 1, we talked about how to contract for BEPS compliance with in the owner architect agreement. And so today we're going to talk about how to really kind of flow down those obligations to your energy modeler, who's probably one of the main key consultants that the architect will retain. I just want to preface this by saying that our preference is that the owner, and I'm always going to talk from a design liability standpoint because that's just prime and grain, but our preference is that the owner retain the energy modeler and really kind of hold that liability. That's not always the case. A lot of times architects will have to do that, and so we're going to talk about how to do that in a way that manages that risk. So a few caveats before we get into it. I just want to mention we're going to talk about this in a standard contract format using AIA document C401. We're also going to use an HOK developed document. And so as far as the AIA is concerned, I have to say this, they're not endorsing how we're using their documents, but we're not going to really be getting that deep into the details on that one. The HOK document is a document for use with our professionals. So again, it's not HOK providing legal advice, but it's just kind of recommendations on best practices. Okay. So as far as the C401 is concerned, if you pop up, there's a little pop up there. What we want to do is first of all, reference our energy modeling exhibit in this portion of the project, and I'll go through that in more detail. Next slide. And then the other important change to the C401 is we want to make sure that we're also identifying the E204 that we developed for incorporation into the owner-architect agreement, the owner-contractor agreement, energy modeling agreement, as we're going to show here, and also into other consultants, MEP consultants that are required for compliance. So Exhibit A, scope of services. So this is where I'm going to go over a little bit of what we talked about in Module 1 again, because I think it's important really to kind of understand where we're going. We use, kind of nondescript language or jurisdictional neutral language because we practice across a number of jurisdictions. So I'll try to bring it back to the St. Louis ordinance as much as possible. When we talk about the building performance standard, what we're talking about is weatherized site energy use intensity by building peer group. And then the authority having jurisdiction is, of course, the St. Louis Building Division Office of Building Performance. The compliance period is really key to this document. What the compliance period does is it sets a horizon on our obligation for achieving compliance with BEPS. Unless you're designing to net zero, in which a lot of buildings that just doesn't fit in the owner's program or budget, unless you're designing to net zero, you really need to define that window that you're going to achieve compliance with the performance standard. And so it's the finite contractual agreement on what is an indefinite obligation on the part of the owner. So just because we're agreeing to a compliance window of 10 years, that doesn't mean that that's the only time period the owner has to comply. What this does is it helps the owner make an informed decision about how much to invest in capital improvements today versus how much they're going to have to set aside and when those capital improvements will have to occur in the future. So the compliance period, a contractually defined compliance period, is just really important for helping owners make that informed decision. We want to define this in terms of years. We don't want to define it in terms of compliance cycles. And that is because there's a lot of things that might impact cycles. There might be pandemics that cause cycles to extend, or there might be alternative compliance pathways that don't really fit neatly in the cycle. So we want to make sure we're defining it in terms of years. Yeah.
It's just from a personal point of view, it seems a lot of my projects in the city of St. Louis just eke under 50,000 square foot, and I don't know if our contracts are written to express that like, are we going to drop the square footage sometime in 10 years and go to 25,000 square foot? And how do we protect our owner from having to? I think
Yeah.
where I'm going. I just don't know how.
Well, yeah. Well, I think we in those situations, you always are designing to the law as it exists that day, and when you go back and try to untangle that in the future, you're going to look at, well, what were the requirements at the time versus what are the requirements now? If in the future it drops down and picks up a lower a lower number of square foot, that's gonna be, you know, that'll change the requirements at that point in the future.
And our owner can come to us and ask us why we didn't.
Well, it wasn't required at the
Right.
time, it's changed.
What I do, like right now in DC, we have a draft electrification code. And so
Yeah.
we're starting to communicate to owners, like it hasn't passed yet. It won't impact the building we're designing right now, but it, may have an impact on natural gas rates later. You might want to put in dual fuel infrastructure. So even at a point in time, the 25,000 square foot, limit hasn't passed yet, but it starts to become under active discussion. If you're in the process of designing a building,
Yeah.
I'd say bring it up. Have a conversation with the owner. Hey, there might be a BEPS on buildings of this size, soon. Do you want to discuss a target that is aligned not just with the code, but with BEPS as well? So I think it's good to have the conversation so that it's on their horizon, and then document it in your meeting minutes so you can go back and point to that conversation later if it ever comes up.
That's very important. So, we're governed by the standard of care. The standard of care does not say we can turn a blind eye to what's going on. If we are aware of the potential change in the future, if it's legislation that's pending, it's really important to raise that. Make sure the owner may decide, look, it's not applicable now. I'm not going to, I'm not going to incorporate it. I'm not going to pay for it now. But we want to make sure they're making that informed decision, and helping them do that is really the goal here.
Right, and I don't know that it lands in the contract language, but the opportunity to do that is in the SHRED, the energy SHRED that's required.
Yeah.
Right, to bring those things up.
Exactly.
So then, once the compliance period is set, then you set your compliance, you set what the building performance target. So what is the BEPS that we need to achieve? So if it's 10 years, we see where BEPS is today, we benchmark our building performance. What is the trend, the movement trend in BEPS, which right now might not be clear in St. Louis, but over time will become very clear. Line is moving, and where do we think it's going to be in 10 years? So this is a very important aspect of BEPS that we talked about in module 1, is that, it's a dynamic standard. It's something that is changing. And so we need to design not just to code, not just to lead, which aren't going to get you there, but to where that target is going to be at some point in the future. And a lot of things go into establishing that target. Of course, first, duration of the compliance period, the trend movement, or if there's an alternative compliance pathway that's been agreed to, what is that pathway, and how does that affect where the building needs to, how much energy improvement is required. So next slide. So here we pulled the, and let me just say this, I don't know that I didn't say this at first, but this entire document is based on ASHRAE 209 standards. So it tracks it very closely. We, again, as Annika said, we believe that's a great risk management tool. It brings consistency across the board in how energy modeling is done. But we've also pulled from ASHRAE 209 the cafeteria menu. And so it does allow us to pick the requirements that the client has agreed to. If the client isn't really sure, we're going to mark, model cycle 6 and one of the others, just to be in compliance with ASHRAE 209. Everything else is then additional services. What we're identifying is what's in the basic services and what are we asking the energy modeler to provide a fee for, versus what will be additional services in the future. Okay, next slide. Okay, so just a few things. So of course, we're going to require compliance with the general requirements of ASHRAE 209. We also have a number of other general requirements that we've added in there that we think are really important. We want to make sure energy modeler is coordinating with the owner and architect, coordinating with the owner's energy consultant. Energy modeler plays a key role in facilitating conversations during the energy charrette or at other key points during the projects. We want to make sure that they're in the lead role of facilitating those meetings. Next slide. Also, always it's really important that the modeler understands what the owner's program budget and costs are, because we'll be looking to the modeler to inform us if there are changes to either the model or the owner's program cost or schedule that are going to impact, what we're doing here as far as energy performance is concerned, to make sure they're updating the architect and keeping us informed. And then just always performing energy modeling consistent with the agreed building performance target. Next slide. Sustainability workshop is what we called it in E204, but it's the energy charrette in ASHRAE 209. It is that goal setting meeting. It happens before design occurs, and it's in that meeting that the owner's goals and objectives are reconciled with their budget and their schedule, and then we set all of the key metrics that are going to drive the process forward. Again, we want all the key stakeholders in this meeting: the owner, contractor if they're available, MEP consultant, energy modeler, commissioning agent, all need to be part of this conversation. And we really think that the energy modeler should take a lead role in facilitating conversations about data inputs into the model, really benchmarking energy use, identifying the owner's requirements and goals and objectives, setting the model cycling requirements. How often are we going to do it? When are we going to do it? And why are we going to do it? What are going to be the outputs of those cycles? And then, of course, really key to BEPS is setting the compliance period, establishing the building performance target, and then identifying performance measure building performance measures. Those are just implementation strategies. So we set a target. Now, what are we going to do to achieve the target? And that's what we want the modeler to really help lead on that. All of this will be consolidated and documented, and that's what I like about this process, is it leads to not just a process of informed consent, but documentation of the decisions that are made from that process. And so out of the energy charrette is a energy modeling work plan that becomes really the basis for how energy modeling will take place. It describes, again, the compliance period, the performance targets, implementation strategies, scheduling for running the modeling cycles, and the timing of modeling reports and how that information is going to be dealt with. So the next slide, just at every phase, whether it's schematic design, design development, or construction documents, there's really just kind of some key tasks that the energy modeler should do. One is make sure that they're reviewing the reports from the prior phase against any changes to the owner's program and schedule and budget to make sure that everything is still aligned. And then advising on any updates to, implementation strategies that might occur as a result of that. And really want again, to facilitate those energy modeling meetings and to facilitate those conversations with the owner and prepare a report at the end of each phase. This just, again, I think just kind of highlights a repeat of what we just said in the contract documents phase. And then I'll go back just one slide. So in construction, and we'll talk about this more in module 3, but construction, a lot of the modeling cycles during construction are optional. But to the extent they're marked as a basic service, we want to make sure that they're tagged here, and we have appropriate times that we think that they should occur. But one of the things that we really think is important is really managing changes to the project. So if you're getting substitutions that impact energy performance, or change orders, that there is a requirement that those all come back through and are modeled and those impacts are understood. The next slide. And then post-occupancy, to the extent any of those post-occupancy cycles are part of our basic services, performing those. But more importantly, really, making sure there's an obligation that the modeler is notifying the owner and the architect if ever actual performance is not matching model performance, so that we can, during that post-occupancy period, really jump in and try to figure out what's going on. We want to know, is it a construction issue, a tweak to the system? Is it a operational, set points need to be adjusted? What's going on there? How can we make, what needs to be done to make sure that we are performing as modeled? The sooner we get in front of that, the less likely it becomes a design liability. So that's a really important risk management strategy. And that just kind of identifies that. So
just a couple things just to highlight, in addition, that are required by the IECC are the air leakage testing. And this is just making sure we're following through on requirements by the city of St. Louis. So air leakage envelope is mandatory in the IECC 2018. And basic fundamental commissioning is also required in order to get a permit.
SEVO.
Yeah, SEVO. Yeah.
We really leverage commissioning as part of your risk management, your performance, strategy. That's why we layered that on with the energy modeling. It's another tool in the toolkit, and why we suggest
checks and balances of the system,
and why we suggest bringing them on board earlier than maybe the code requires you to, because this is part of ensuring a building performs the way it's intended to.
Yeah. So prior for occupancy.
You have to do it anyway. Might as well do it right. This is a building, so DC's had benchmarking for several years now, and this is a building we designed. It was the second LEED Platinum Cornerstone building in DC, and I have the design EUI up at the top, and then this is several years of performance, and I just wanted to show how buildings drift. And so when our Clean Energy DC Act passed, you can see their oh heck moment. And you can see that they did bring it back in line, and it actually is now performing better than it did when we modeled it. Most of that is operations. They did do one minor capital improvement, but most of it is operations. They started staggering their startup and doing some other things. And so our client, the developer, sold the building to an investment fund, so it's a different owner now. They shared their report on the things that they did to improve building performance. But I just wanted to showcase that lots of buildings don't perform the way they were designed to perform. And until someone actually focuses on operations and maintenance, drift happens. That is like a 50% deviation from the design EUI. So why do buildings perform differently? Some of it is O&M. Go ahead. And so some of it is occupant behavior. There can be a lot of plug load issues. So we have some things here that are like, what can you do in design and construction to influence better outcomes on those factors?
Becky, if you could mute yourself.
Yes, Becky, please mute. Thank you.
Yeah, thanks.
Okay, I have to go back. Yeah, so I won't go through all of these, but it's things like sub-metering tenants, if it's a tenant-driven building, potentially having something in the lease, if you're an owner, that holds tenants accountable for their energy usage, having a really good O&M plan and O&M training and making that iterative. It's not a one and done, but every couple of years, every 18 months, having good experienced, not just MEP commissioning, but enclosure commissioning consultants, updating that energy model during your phases and at delivery of the building so that you know how the building should perform. So there's lots of things that you can do in the design process to hopefully help position the building to perform better. And handing over a really good package if you sell the building of information, and like this owner did when they sold the building, making sure that good O&M plan and training protocols do transition with new ownership.
And you said there was a little bit of capital improvement there, but
They added an energy recovery system, basically an enthalpy wheel, because they didn't have one. It was built, before that was really in the code. So they added an enthalpy wheel for energy recovery, but most of it was O&M protocols. So we said in the last one, people asked about incentives. So if you have, whether it's a new building or an existing building, the Inflation Reduction Act does have some incentives to help you with your high performance design or renovation. 45L is for home builders, and it applies to larger multifamily buildings now. It used to just be for low rise and single family. So $2,500 per unit for meeting Energy Star, or $5,000 per unit for the Department of Energy Net Zero Ready. Takes effect January 1, and it's a 10-year extension, so it's good for 10 years. 179D, it's $250 to $5 a foot. If you're doing new construction, it's a 25 to 50% improvement on, and it's an evolving ASHRAE baseline, so it's going to continue to update over time. This is a permanent tax credit, though, so it does not expire. It used to expire every 2 years, and then they made it permanent. It continues to be permanent. It takes effect on January 1, this new. Now, the exciting thing is, for existing buildings, you're looking for a 25 to 50% improvement on your existing building baseline, not on ASHRAE. So it's much easier to achieve 25 to 50% improvement on your existing building baseline than on an ASHRAE 90.1 2019. So this is actually very attainable for the existing buildings who have to do this work under BEPS. You can get $250 to $5 a foot, depending on the level of, and it's a sliding scale depending on the level of improvement. There are some additional requirements like prevailing wage and some other things. So you may not get all $5 if you don't pay the prevailing wage to your construction crew.
If you're a design firm and want to take advantage of this, you need to make sure that you carve out a right to ownership of intellectual property related to research and development. So a lot of times owners will ask us to give away all our ownership rights to intellectual property, but if you do, you won't be able to take advantage of that.
Yeah. And if the client is a nonprofit or institutional, doesn't have a tax liability, design firms are eligible for the tax credit if you don't give up your intellectual property. 30C EV infrastructure tax credit expands and extends through 2032, another 10 years. 30% up to 100,000. But if you don't meet the prevailing wage, then it can reduce down to 6%. Go ahead. And then the clean electricity tax credit. This is a credit up to 30% of your costs for things like solar and other geothermal, combined heat and power. So even microgrid, it can be just a single building technology, or it can be a larger district energy solution. They've also expanded it for energy storage, dynamic glass, and starting in 2025, it's going to be a technology neutral that will be based on greenhouse gas emission reduction. So open it up to things that maybe they didn't think of when they wrote the Inflation Reduction Act, which is pretty cool. And so if you're looking for incentives, the first two websites are really good resources for state and local and federal. And then if you're looking for what I just showed you for single family homes, low rise, multifamily, high rise, the USGBC had a really good summary, and the AIA has a good memo. So those next two links are the USGBC and AIA's memos. And then I hosted or helped introduce a webinar, which I mentioned at the last module. And so that last Zoom link is the AIA USGBC combined webinar on the Inflation Reduction Act, and the passcode to watch it if you'd like to. We sold out Zoom, like it was 500 max, and so they made the recording available. But those are all some good places to find information on incentives, because it's one thing to make you do the good work on these buildings, but if there's money available, you should absolutely. We'd hate to see people not do zero energy or zero energy ready buildings just because they didn't know how to get access to the incentives. So that's it. Any questions for us?
perfect timing.
The retrofit incentives, was that year over year for 25 to 50%?
Basically, and they're going to be publishing more information on the DOE website, but basically it's probably going to be an average of a couple of, baseline years, but it's an EUI improvement, 25 to 50% improvement over a baseline EUI performance. And you already have that data because you've been benchmarking. So yes, you'll have 1 year's performance and you'll show the 25 to 50% improvement.
Those incentives that you just showed at the end, Do we think that building owners are aware of these at this point? Or-
No.
Okay, perfect. Yeah, I mean, if I can get a copy of the slideshow, that'd be great, because that was.
Yeah.
So this presentation and slideshow will be available on the BEX STL website very soon.
Yeah, I just shared this with one of our developers we're working with in DC, and they were like, where's all this? How's it? Like,
Right.
they didn't have the information, like, developers should be the first to know the information, they didn't, and I don't think they're aware of it. Now, a lot of the details of these policies will be, if not sooner, January 1, most of it will be, Treasury is passing off a lot of it to Department of Energy, so a lot of it will be, the details will be on the Department of Energy's website.
179D's been around a while, though.
It has, but it's changed. So 179D used to be up to $1.80 a foot, and it was 3 buckets. It was envelope, lighting, and HVAC, and that was it. And then it used to expire every 2 years. And so then it was like, well, like, who's gonna make design decisions if you don't know if the credit will be there by the time the building's built?
Have they clarified if it's available to owners or,
179D?
yeah,
No, it's definitely available to owners. I don't. Yeah, and so the clean energy tax credit is it can be a direct incentive. It doesn't have to be just tax based. So like you can get direct cash incentive. But yeah, 179D is if you have a tax liability, then you get that incentive, and if you don't, it can convey to your consultant. So for
yeah,
owners who are
because the
nonprofits.
statute, I think, was written where it was, the design, it was written in, as a design professional, it wasn't clear, and the owner allocated it then to the design professional.
It goes to owners first, and then if the owner doesn't have a tax liability, it can convey to a design professional. 45L does not convey, but if you are doing like low-income housing, anything else, like a nonprofit developer, you can apply for like LIHTC credits and things like that. One thing they did do is remove the conflict between LIHTC and 45L, so you don't have to choose between them. You can qualify for both if for some reason you're able to.
The updated 179D, I guess for new construction, is an evolving 90.1 baseline.
Yeah, and so I think it's something like the 90.1 that was in place for a certain number of years.
It was
before
very
you-
outdated baseline.
Yeah, the old one was, and so it'll basically be, I don't know if they're gonna start with 16 or 19, but it'll basically update based on when your project got started. It'll be like the standard that was in place before your project got started. And then it'll, so that's one of those things where the details will be posted on the DOE website, but they wanted it to be something that's self-updated instead of being stuck with like a 2007 standard forever.
And have to pass legislation in order to
Yeah.
get it done.
But yeah, so.
And how much has the city of St. Louis, kind of, you might be able to help out here, have there been exposure to the design build, mechanical MEP installers for, I assume you're one of them, but Gerald.
But I'm the only one here.
Right. I mean, because I'm working on several buildings that have design build partners that I'm not sure if we're gonna get an energy model. I'm not sure if, I just wanna
I know.
have a heads up.
Yeah, we do have a website, stlbenchmarking.com, where you can go and get all the information and doing seminars, personal sessions, spreading the word. So
Yeah.
call us and ask us questions.
Yeah, because I definitely want to get everyone on board and
Yes.
just at least aware of everything that's happening, so.
Other questions from online? You wanna-
Yeah, feel free to unmute yourself if you'd like to chime in with a question.
I think David, your question kind of lends itself to Malachi saying a couple of words about the Building Energy Exchange.
Yeah.
And what it's really meant to do here in St. Louis, so.
Yeah, so I firstly, I want to thank HOK and Annika, Donovan, and Allison for providing such a good resource to our community. I think it goes to, it speaks to the fact that we're all living and building on this planet together, and we couldn't do this without shared experiences. And so the Building Energy Exchange exists to fill that gap, bringing not just helping building owners comply with legislation, but helping people understand that we can provide better buildings that create a better situation for occupancy and a better situation for operations and a healthier situation and a more productive situation. So we can do all that and be nice to our planet at the same time, which is kind of grand. One thing that I want to note, which is what Emily's hinting at, is that we are working with the Building Energy Exchange in New York, the BX in Kansas City, as well as IMT, the Institute for Market Transformation, on a series on the Inflation Reduction Act. The first one of those is coming up on October 26th. There'll be more information about that coming out. So there will be some information that we will be sharing collectively.
More detailed than my 5-second.
Yeah.
Overview.
But we're also very open to feedback. So if you're finding issues, please let us know, because hurdles are what we're designed to help people overcome.
Yeah, and this came out of, you know, we'd spoken, I think, to the LFRT about some of these issues, and then the DC Innovation Hub asked us if we could do some education, and then, you know, the Building Exchange, Energy Exchange here, you know, it was like, how can we share these resources as broadly as possible so that.
Decode though, large firm roundtable is.
The LFRT, the ARA Large Firm Roundtable, because, you know, ideally, these practices are not about risk mitigation, they're about actually achieving better buildings, you know, but we kind of take that dual pronged approach of, like, we're talking about energy early and often, and, you know, we feel like there'll be better outcomes at the end of the design process because we set these targets early and we iteratively measured energy throughout the design and delivery process, and we're helping our clients understand why this stuff is so important. But it is also risk mitigation, right, at the same time. But it's a collaboration of all of these different organizations who are building tools on top of each other's resources and collaborating. And so it's great to see, like, these cities and organizations working together across the country to make this happen. And so I just think it's really incredible.
I think there was a collective freak out in the design community about these. I know being on the large firm around LFRT, legal LFRT, listening to my colleagues at other large firms. I think as you dig into it and you learn more about it and you understand how they work, that freak out is less there. We're hearing a lot about it from our insurers, though. They're asking a lot of questions about, you know, what does this mean? What are you doing about it? So being able to have a response to them, you know, that it's not risk, it's manageable. Yeah, I mean, it is a risk, but it's manageable like everything we do. There's a risk there. I think that's important. So.
Any other questions before we wrap up? Thank you guys for coming. Grab a snack on your way out. And if you have a chance, check out the cool stadium model over here too. So, worth coming in for.
Are we able to plug it in? And turn
Yeah, I'll put the.
And so our next module in 2 weeks is on construction documents and construction administration and turnover. So we'll talk more about, like, Division 1 specifications and then substitution requests, change orders, and how we manage this in the construction process. So thank you very much.
Thank you.
Will that one be solely online?
I don't decide.
I'm not sure if we've decided yet.
We'll
let you.
TBD.
For basements.
We don't.
Yeah, we'll take a look at this. I don't think we have an answer to the size. Thank you so much.
Thanks.
And also because